Cumulative fracture dimension chart is a new function that has been added to the version 3.12. The whole point of this 2D chart is to be able to demonstrate the fracture center, the fracture dimension, and also the fracture azimuths varying as a function of time. If you imagine the microseismic events in 3D space is growing from right to the left, the best fitting box, as you can see here, is actually varying as a function of time. The best way to capture this information is to plot the fracture center, which is the center of the box, the fracture dimension, which is the dimension of the best fitting box, as well as the box azimuths as a proxy to the fracture growing azimuths, and plot them as a function of time. Here, I demonstrate the accumulated fracture dimension chart using these project files again. The fractures are actually growing from where we do the perforation shot. If I play the events as a function of time, you'll be able to see the fractures as growing, start from the perforation shots and grow all the way to the left, and also migrate to the top, and also have fractures on the top. To plot the fracture dimension chart, we go to Tools, Parameter Visualizer, and there's one that I have created. You can also click Add and create an all-new cumulative fracture dimension. I'll use the one that has been created. Click Edit. I'm able to change the parameters. The chart subtype, you can choose either the linear time or equal bin size, because the number of fractures are growing with time, sometimes faster, sometimes slower. So if you use a linear time for different time window, you may end up different number of microseismic events. To balance that, you can choose the second option, which is to make sure you choose a time window, and every time window you'll increase the same amount of microseismic events. So I use this option, and every time I increase one step of the time window, I'll increase 50 events. The remove outlying events is going to remove the events that is 2 times the standard deviation away and consider them as outliers, and those events are not going to be used to fit the box. Grid volume is the calculation volume in 3D, and this is the display legend here. If I click OK, double click that, so here is the results. On the top is the fracture center, and the middle is fracture dimension, at the bottom is the azimuth. So basically you can see the fractures growing slightly to the north and slightly to the west. So it's northwest. If you look at the fracture dimensions, the length, width, and height are actually growing as a function of time. And same with the azimuths. Initially it starts from 65 degrees from north and approximately going towards 90 degrees towards the north. That's basically east and the north. If you choose the linear time, then you're going to see something different. For example, I'm switching that back to the linear time, and you'll see at different time you will have slightly different number of microseismic events. But in general, the fracture dimension is increasing with time, and particularly the fracture is actually growing to the top, and that actually reflected here as the height. If you're happy with the results or want to do some further analysis on these results, you can actually export as a task file, or you simply save them as an image file that can be included in your report. Thanks for watching.